So between 1,000 and 1999, I see 1, 2, 3. Is that just 3? Between 2,000 and 3,000, 1, 2, 3, 4. Okay, and then between 3 and 4,000, I see 1, 2, 3, 4. Correct me at any point in time. And for the last one, above 4,000, 1, 2, 3, 4. So obviously I'm missing 1. So between 1 and 2,000, 1, 2, 3, 4. Yeah, got it. So obviously in this case, every the relative frequency will be simply 0.25 for all of them. And again, we did not really discuss the cumulative relative frequency, but it's very simple. So the cumulative will be the first one, 0.25, then the first one plus the second one, 0.5, and then 0.5 plus the next one, which is 0.75, 0.75 plus the last one, which must be exactly 1. That's the cumulative. I don't need it. So we know how to create a relative frequency. What if I'm asked to present the histogram? This is continuous data, right? Because we have classes. Now, if this were, for example, a discrete random variable, so this will be a histogram, but this will be a bar graph. And I will give an example in a second with the bar graph. So not to be confused, the histogram is for continuous data set. So if I say this is 1, 2, 3, 4, and this is the relative frequency, okay, and of course I always have to show that they add up to 1. So that was on the side, the cumulative relative distribution, but what we need to show always that this adds up to 1. This is a key. I cannot give full credit if you don't check and not just write 1. You have to check and make sure that they add up to 1. Okay. So now for the histogram, between 1,000 and 2,000 basically. So this is 1,000, this is 2, this is 3, and this is 4, right? So then I have, let's say this is 0.5. So 0.25 will be right here, 0.25. So then this, and this till 5,000. So all of them have 0.25. If it's not a histogram, but it's if it's not a relative frequency histogram, but just the frequency histogram, then I will have 4 here, 4 here, 4 here, 4 here. I will write them in. You can write 0.25 right now on all of them, but they are the same. Now, an example for a bar graph, right? So if we have qualitative data, for example, let's say red, green, purple. And let's say I have 10 and 15 and 7. So I have to add them up. Let me run this up so it's nice so I can divide quickly. So this is 30, right? 20 plus 10 is 30. So 10 divided by 30 is 1/3. 15 divided by 30 is 1/2. And 5 divided by 30 is 1/6, right? So they have to add up to 1. If they don't add up to 1, then I'm in trouble. So now, if I am asked to graph the bar graph, let me refresh your memory. These bars are equal in width, but they cannot touch. So this is for red, this is for green, and this is for purple. So now if you want to use the frequency, if I'm asked this frequency bar graph, then I will use the numbers. If I'm asked to present a relative frequency bar graph, then I will use the percentages. So if I want to, let's say I'm somewhere between 0 and 15, so 5, 5, 5, so 5, 10, 15. Sorry about that. So then the red will be as high as 10, and I put 10. Green will be as high as 15. And this is a refresher. I know you remember this, but just to make sure. And then the purple, 5. So notice that they cannot touch. These are not classes. These are categories. These are classes. So if I'm asked how many classes, I will say 4. If I'm asked what is the lower class, for the first one, let's say, is 1,000. What is the upper, right? The upper is 2,000. So what is the class width? 1,000. Okay, so that was problem 2 that I wanted to look at. Again, you can stop me anytime if you have other questions. Then I would like to, which one is the next one I marked? Yes, I wanted to go to problem 15. So let's scroll to 15. I will post these answers for you. We're going to cover as much as we can. If we can finish it, that's even better. I also recommend this table. So print out just this page. It's also, I'm going to show it to you in the midterm formulas. I'll show that to you in a minute. So I wanted to look at 15. Okay. So the data on the right represent the number of live multiple delivery birth, 3 or more, in a particular year for women 15 through 54 years old. Use the data to determine the following. Okay, so first I have to copy the data because why? Can anyone tell us why do I need to have it?
So you can like get the total number.
Exactly. Thank you very much. Yes, that's it. 30 to 34, 35 to 39, 40 to 44, and the last one, 45 to 54. Okay, so then we have 94, 508. If anyone could give me the total, that would be fantastic. I'm not lazy. I can.
The total is 7,395.
7,395?
Yes, ma'am.
Perfect. First question. Determine the probability that randomly selected multiple births for women such and such involve the mother 30 through 39. 30 through 39. So the probability for 30 through 39, what will I answer? Don't give me the final answer. I just want everyone to see what we're doing.
You would add up the 30 to 34 and then the 35 to 39 together.
Yes, because it's 30 to 39. So we have to add these two together and then divide the total, this sum by the total, 7,395. Excellent. So what do we get here? So it's a 9, it's a 7, 4, 6. Is it 4, 6, 7, 9?
Yes.
Perfect. So now we have, I lost my calculator. No, I didn't. So 4, 6, 7, 9 divided by 7,395. And it is better to use 4 decimal digits. So 0.6327. So that was part A. Let's see what they want next. Determine the probability that a randomly selected multiple birth for women 15 through 54, 15 through 54, involve the mother who was not 30 through 39 years old. So not 30 to 39. That is the complement of 30 to 39. So we do have the probability for 30 to 39. We just determined it. How do I determine the probability of not 30 to 39?
So since we just added the 30 to 39, which is 4,679, you subtract that from the total amount of births because that's all of the other.
But we already have the complement is 1 minus that. That's exactly it. Is that clear? Is that okay?
Yes.
Yes.
Perfect. So 0.3673. Oops, I didn't mean that. I meant for you to see what I'm writing. Sorry about that. I just realized that I was still sharing my screen. Good. Next question now. Part C. Stop me if you have questions, please, anytime. Determine the probability that random. Yes, go ahead. Anyone? Determine the probability that randomly selected multiple birth, such and such a mother who was less than 45 years old. So not 45, less than 45. I'm not going to add these up. I will do this. So x less than 45, I will say 1 minus 115 over 73.95. Right? Who was less than. I don't want to add those. I just want to add, I'm going to subtract from the probability of the sample space. I'm going to subtract what is left because this is much easier. It's just 1. So the probability in this case will be 1 minus 115 over 7395. So 0.9844. Any questions on that? Okay,
No, okay.
Everything okay?
Yes.
Okay, next question. Determine the probability that randomly selected multiple, okay, who was at least 20 years old. So x greater than or equal to 20. So now they want us to add all these. No, I'm not going to do that. I'm going to do 1 minus 94 over 7395, which is the complement event. This. Will you get the same answer? Of course. .9873. Okay, that was 15. I wanted to move on. Any questions for me on this one?
No.
Okay. Moving on. Stop me if you do, please. Okay, so let's look at 16. Why did I select 16? Oh, I see. So here is a different data set and table. So this is 16. And we have never, former, current. Okay, 516, 63, oops. I messed up my table. I'm going to have to start it again. So if you want to give me any totals, good. And then I'll come back.
The total in the died from cancer column, the D column at the bottom will be 765.
The did not die total is going to be 140,262. The total for the never smoking cigars is 122,587. The total for former smokers is 8,470.
Yeah, that I see. And here is
And
9.
970. 9970.
Oh,
sorry.
okay. No worries.
And I haven't added the total yet, so.
Okay, you do the column and I do the row because they have to be 100%. Okay, perfect. All numbers check. Good, so now let's go back and see what we're asked to determine. Okay, we have four parts here. What is the probability that he died from cancer? So if we select one person at random from this study, what is the probability that she died of cancer? Then is the probability, okay, what is the probability that he was a current cigar smoker? Okay. If any individual is randomly selected. Okay, and then and was a current and or. Okay. Good. So we have 4 different questions. So probably that he died from, the individual died of cancer. How do I determine that?
I'm not sure if this is correct, but do you just divide the total number of people that died from cancer, so 765 divided by the total number of people
Absolutely. Let's find all of them and then we'll plug them in. The next one was asking us to find the probability that he's a current, right? Current cigar smoker. Current smoker. How do we get that?
The total current.
Yes, go ahead.
Go ahead.
Anyone.
The total current over the total.
Grand total. Very good. Awesome. Now they want and. How do we get the and?
Wouldn't you multiply the 2?
Careful. Careful. Because we have the table, it's this. The intersection over the total. The intersection over the total.
So it'd just be 186 over the grand total.
186 over 141,027, and we can get those numbers. I don't really care about the decimal numbers right now. And finally, we want the or. And at this moment, we don't need the table. We have everything we need here. So now remember the question is are they mutually exclusive or not? If they are mutually exclusive, then P of D plus P of current, done. But if they are not mutually exclusive, and if there is an intersection when they happen at the same time, then we have to subtract the intersection once. How do I write that? Are they mutually exclusive or they're not? Can they happen at the same time?
Yes.
Yes, so they are not mutually exclusive. So then what do I have to write? P of D
plus P of C minus
the intersection.
intersection, yeah.
Very good. Exactly. So 765 over 141027 plus 9970 over the same thing, and minus 1 time. And of course, I'm not interested in the number right now. So we can always divide and add and subtract. Okay, that was the next one that I was interested in. Let's see what else I selected. Yes, I did select 4. Let's see. And then I'd like to go back to chapter 4 to see what Sasha had in mind. So let's see on 4, why did I select 4? Yes. Do you think we have any difficulties with this? We're given a sample. It has 5 numbers, 5 entries. If you want, find the sample variance and standard deviation and mean.
No, I think we're pretty good with that. We can just do